And so you can see that, huh? All right.
Good.
All right, Dave.
Great. So let me set this up a little bit. The idea for doing this, and White followed back up with Garth that the group here might be interested in this. Are we going to? We're recording. Good. So you can put this up, and for people who couldn't have made it, if there's some interesting stuff for them. And it was in recent projects working for different government agencies with different software groups that the DevSecOps word was becoming more and more popular. And in looking at some of the people working on the DoD and government agency side, we were noticing a bunch of difficulties arising that were sort of moving the direction away from something that John actually was critical in starting about 12 or 13, 14 years ago. That's taken over the software world as an infrastructure providing valued services. And we all depend on it, especially in the pandemic. And we depend on it even in many times when we don't think we depend on it because we're trying to stay away from that kind of infrastructure and the issues it brings. Its capabilities are so tempting that it starts to appear everywhere. So the idea is we want to talk a little bit, and we're going to do this kind of in a chronological kind of way, starting with what John was doing 13 years ago and bring it up to today and try to draw out some lessons. The key idea when I talked to Garth was we wanted to give something that could chart a pragmatic course for people. There's lots of stuff we want to talk about at a high level about complexity and adaptation. There's new science results. John Doyle has new results that compete with some of the, well, I don't think they compete, but they're not quite the same as some of the results I have. We could talk about the science. It gets abstract and people lose track of where are the practical implications. And so we want to talk a path of what's underneath all the stuff. When people say, I'm going to use AI, or I'm going to do this autonomy or whatever, underneath this all is software. And here are some of the lessons we've seen and have developed over this time frame and how it's relevant to what we see is going on in general in the commercial side, but also in the government and defense side. And the simple critical line here to start with is fundamental from all the stuff we've talked about in adaptive capacity as a theoretical fundamental concept, which is how do you provision systems now to adapt and learn later when growth produces SNAFU? And so that kind of summarizes what the talk's going to be about and where we're going to go. And so we're going to go back to the beginning, and that was John. So John's going to talk about.
Right. Thanks, Dave. So yeah, the DevSecOps, of course, leans and is based on this original notion of DevOps. And so I'll give you a little bit of color around that. So around 2008, 2010, a number of folks, a book was written, which I wrote a foreword to, Andrew Clay Schaefer and Patrick Dubois. Patrick on the right, the person who coined the term DevOps. Basically, this notion that a couple of things fueled this, which was this small but very quickly growing at that time community, mostly of people who were responsible for building and maintaining and handling large-scale software services, largely what I would call internet-facing consumer services. So there's this realization that software just can't be built correctly, as in the way that you build it in the way we used to say we shipped software, we literally ship a CD. It has to be operated, and that in production, software has, in some ways, lots of surprising behaviors. In this way, it meant that there was this fundamental assumption that there was a boundary, there's some idea between application developers, people who are writing the software, and systems administrators or operations engineers. These roles just had this boundary was manufactured, and it didn't really serve anybody any good. My colleague, there's a screenshot here, my colleague in 2009, Paul Hammond and I gave a talk that's quite often, along with Andrew and Patrick Dubois' work, seen as the origin, the genesis of this idea of DevOps. Central to this idea was the notion of continuous deployment or continuous delivery. What's the basis of that? The idea is that there's this acknowledgement that how software behaves in the real world, it can't be predicted in its behavior or even in its value, or anticipated comprehensively. As a result, a number of techniques or certainly practices came out. Dave, when I first explained this to Dave Woods way back, he pointed out, well, what you've just told me are hedging strategies. What do these include? These include a general stance, almost a sort of a global stance, that small changes made frequently have benefits, outsized benefits over large changes made rarely to running, executing software. This notion, technique of feature flags, configuration flags, that is to say, knobs and levers that allow the running functionality to be adapted while it's running, not just at the begin, not just at sort of launching the software. We're all connecting on Zoom right now. I can guarantee you that there's at least one of us on this call who, as the Zoom user, has a feature flag or an A/B test flag turned on. We may not be able to see it. It may not be visible functionality, but I can guarantee that it's happening. Percentage rollouts, that this notion that it's not an all or nothing situation. When new functionality, even invisible sort of underlying infrastructure goes out in percentage. Allow block lists. This group can check out this new thing and this other group can't. Staff only, application and system level telemetry coming together. And these are relatively new ideas. These strategies, you'll notice I didn't have anything about testing in here. Of course, testing is important. It's what most people have in their mind, a sort of mental model, is we have to have better testing. Well, I'm going to point to a colleague of mine, Noah Sussman, gave a talk at the Association of Software Testing. And he posits that, which I agree with, that we do not asymptotically approach complete testing, that complete and comprehensive testing prior to deployment is not a thing, not a thing. In addition, of which we can test is that there's things that we can test because we know we need to test it. And there's things that we don't know we need to test. And then there's the things that we know how to test. And these, this sort of framing brings you to this idea. If we try to be comprehensive in our testing, then we'll end up being too slow and able to keep pace. This means that testing is necessary. It's gone leaps and bounds with automation, automated testing, all sorts, but it's insufficient. And DevOps as a paradigm acknowledge that. So a couple of ideas here, if I were to sum up in a relatively snarky way. No software survives first contact with production. All successful organizations, the largest, Amazon, Facebook, Twitter, eBay, Netflix, all of them understand this as grass is green and the sky is blue. Preventative designs have real and consequential limits. And that is to say that surprises are guaranteed. There will be scenarios and surprises despite any of the preventative designs that you put in place. And so therefore, these investments have to be made ahead of time to support people responsible for handling those surprises. And these surprises are what Dave has referred to as SNAFUs. I'll give this to Dave. Dave, you can pick up here.
Right. So this was going on, and John had been trying to get me to come and talk at Velocity, the big conference where DevOps was growing, and he wanted me. I'm not quite sure what he wanted me to do, so I was reluctant to go, and I wasn't sure I could say anything interesting. And he finally got me to talk about the resilience and the science behind it, and where it was going, and what we'd found out so far. But in hanging out there and visiting with everybody, I kind of looked at him and said, this isn't about the stuff I've done. This isn't about what we figured out before. You actually are anticipating and exemplifying a future that people claim they want to create. Only it turns out it's not remotely as advertised. It's already here. And looking back now can see this as a paradigm shift. At the time, he didn't know this was going to take over. This is fundamental to where the companies that you rely on in everything you do, and often in ways you don't understand. And you also have people saying, well, we're gonna move this to the cloud, for example. Well, what's that? That is another organization working with you. And we'll talk about how this all plays out. But very quickly realized this was the world. This was the instantiation. This was the laboratory in which the stuff I was talking about adaptive systems and complex worlds was already playing out, where we could not just see the phenomena of complexity, but we could see the phenomena of adaptation. It was highly technical. It was highly automated, all kinds of things that gave us an opportunity to learn, and also to use that learning pragmatically. And we're going to focus on the pragmatic, not on all the higher level concepts. But the one we have to hit on is adaptive capacity. Everybody wants to put definitions out there. The one that matters the most is this. Adaptive capacity is a system's readiness or potential to change how it currently works, change its models, plans, processes, behaviors, to continue to fit changing situations, the anomalies, surprises, exceptions that will inevitably come forward. Now, this is something, and I'll talk about this, I'll focus on just this next month, where I'll do a whole talk just integrating biological examples of this, how the biological world always does this. They select for future adaptive capacity, and how that also connects to our results from joint cognitive systems, people in automation, people in AI, and also to human systems at other scales. And we're going to integrate that there's some fundamentals there about where this comes from, why this happens, and some techniques that are used across biology and cognitive systems, things that you might be interested in, given some of the things you've mentioned already. But that's not the story for today. Today, the idea is that this potential means you have to invest in it in advance of when you need to behave to handle the surprises. The example here is when John was talking about testing, he was referring to testing in our usual sense of it, where we show it's good, it's validated, our T&E system, and then we launch it, or we accept it, we deploy it. It's of a different kind of system in defense acquisition. It's once over the hurdle and away we go. Instead, what John and the others were doing was building not just small deployments, small changes. It was also the design, and many of the things he ran through as hedging strategies were small, inexpensive ways to get feedback, to get information, to constantly be in a process of saying, is this really working the way we thought it was going to work? What's new, and how to adapt quickly to that new information. Next one. So what happened coming out of that meeting about 10 years ago is I said to everybody, I know what's going on. You are inventing bottom up how to make this work. And you're taking over. Everybody's using this stuff. I said, what we need is a way to integrate and share results and abstract those and generalize those, and then take them out to other settings where these apply. So what I created with a variety of groups, this is when John was CTO at Etsy, but we put together a industry university partnership called SNAFU Catchers. That SNAFU is the natural state of systems. You heard me talk about this when we were able to physically get together there. at Carter Rock, and SNAFU catching is essential. And it's on a, by the way, that is on the side of a plane from World War II in the Pacific Theater. They were called SNAFU snatchers for rescuing downed airmen in the Pacific Theater. So we adapted that. And it was trying to understand how we really cope with complexity, these key phenomena, and especially develop practical stuff with industry, financial, software, other kinds of groups being critical in it. These were the original one. Do we have all of them? Yeah, we have all of them there. And so this moved forward with a bunch of findings. Next one. One of the critical ones is the Stella report we did. There is a new, we'll give you the link later. You can get a special issue of ACMQ that runs through a series of findings from a variety of studies, all working with real industrial partners on what really happens out there. A bunch of things are relevant there. I will not mention many of them right now. It's available to go through and stuff. However, we were reminded quite recently, and John's going to refer to this idea of strange loops. Everything you were talking about in complexity and all the aspirations you have to get more capability in a changing, threatening world, right, ends up somewhere, somehow turning into software. And you end up with these strange loops. And every time we go look, we're not looking for strange loops, and we can't help but find them. That's where, in order to do something, right, you need software. But that software has turned out to be impacted by the reason you need to do something, right? Because a problem has arisen or whatever. And these two go hand in hand, each undermining and impairing your ability to move forward. Basically, the complexity of these systems has overwhelmed our ability to understand them. So we start, like John did, now with the assumption from the results here that our models are wrong. And that may not matter now, but it will eventually. And so part of this process that John had, we extended through the work in the consortium to say we need continuous updating of the models or recalibration. And much of the work we're doing with practical everyday companies that are critically software dependent or are software companies themselves provisioning these things is based on that. Now, one of the other findings, if you go back for one more second, and what helped motivate us to do this is we started to recognize backsliding. Remember, the paradigm shift was more continuous, right? Smaller steps, ongoing, lots of feedback. And we started to see backsliding where people were starting to put barriers. And we saw the rise of more and more multi-party interdependencies. Even big software houses became dependent on other kinds of companies, other kinds of organizations that undergirded things, and for them to be faster, to keep pace with change and to supply their customers, and some of the companies in there supply you in the defense business. In order to keep up, they had to change from a monolithic approach, and multi-party interdependencies became more and more prevalent in the cases we were looking at. And that has continued. And recently we've been struck again by how this has grown and hobbled or even turned backwards the clock on this great development in continuous development and deployment. That then led to what you all, if you heard the talks or watched the talks later that people like Dave Alderson and I did at the complexity meeting and some of the others, it's easy for everybody to say, hey, Dave, this is cool. I understand this stuff. It's a neat way to think about complexity and adaptation. What am I supposed to do with it? And, you know, as we heard about this more and more, and as we worked the consortium, a lot of the companies said, what we really want you to do is work with us one-on-one. We don't want to share the information. We're not worried about what the industry as a whole do. We've got problems we need to work on. And these were already companies that were doing a pretty good job of this. And they needed help to understand and extend what was started by John and others in that paradigm shift that DevOps represented. And so we worked in many different sectors, and we've begun recently to start working more on government software. and acquisition issues. Next one.
So so we're going to take a little bit of an aside, just a couple of minutes. I want to give you some framing, some sort of bit of language that we'll refer to later, but I want to just sort of follow me on this particular framing. The way this goes is that we're going to start with this sort of description of a very typical enterprise software systems, right? And there's going to be a above the line area and a below the line area. So I'm going to walk through what that looks like. So typically it's quite common to see a picture like this, right, as the system, you know, conceptually. You've got the people who are using or consuming the service that you're producing. That, by the way, might not just be individuals like ourselves using Zoom, but it might also be other organizations that use that service that you're providing to provide services for other people. So what we have here is, you know, your delivery. We have your database. You've got your source code, applications, that sort of thing. Of course, if we see this as the system, we'd miss a whole bunch of stuff. And so what we're going to do is we're going to sort of connect this up to all of the things that organizations use to make that service product work. And this includes deployment tools, code repositories, testing tools, and all of that sort of thing, monitoring tools. We could say that this is the system because a lot of, at least say, software-centered organizations spend a lot of their time in this. But of course, this is also not really, it's missing a big part here. And so we're going to just draw this line, call this line of representation. And above this line, what we see are all of the folks, all of the staff who is responsible for getting stuff ready to be part of the system, adding stuff, fixing bugs, new and sort of legacy architectural framing, and keeping track of what the system is doing. And so now in this representation here, you'll notice that each one of these people in the diagram here has some sort of mental representation of what that system is below the line. And if you notice, if you look a little closely, you'll notice that none of them have the same picture, right? Nobody has the same representation, which is very characteristic of complex systems. And so to summarize, right, we've got your product or service, of which maybe others are using as building blocks for their service, the stuff you build and maintain with, and here this above the line is where work is done. And so I'm gonna play this out a little bit further. This is this framing of the world. We end up with this sort of annotated sort of model. It's got this line of representation going through the middle, and people are interacting with the world below the line via these set of representations, right? Your interactions are never with the things themselves, really. You're not actually changing per se the systems. What we're doing is interacting with a representation, and that representation is something about what's going on below the line, right? And so you can think of those little green things as the screens that, say, software engineers are looking at during the day. But the only information that they get about the system comes from these representations, which, in fact, of course, are really just but a very sort of narrow keyhole. That information is that we have about the system comes from those representations. And what's significant about this, all of the activities that people are engaged in, the observing, the inferring, the anticipating, the planning, the replanning, the reacting, all that stuff has to be done via these representations, okay? So there's this world above the line and world below the line. And even though we will, especially technical staff, will really refer and sort of discuss things below the line as though they're very real, right? As though it's really concrete. This is the real rationalization, the real realization that we had, which is you never get to see it. They never get to see, they're in a real sense, below the line, right? You never, for example, you never see code execute, right? You never see the systems actually working. You take me to a data center and you can't point to, this is, oh, and here's your request to go buy this thing on eBay, or here's the video stream from one organization to another. You never are actually touching those things like you would in the real world. What engineers are and people are doing is manipulating it, manipulating a world they cannot see via these representations, and that's the reason why they need to build these mental models, the conceptions, their understanding about what's going on. So those are the things that are driving that manipulation. It's not as if the world below the line is doing it. It's their conceptual ability to understand it. And so what we've been doing with this frame is paying attention in really even in a traditional cognitive systems engineering way, is looking closely about what's happening and driving these cognitive activities up and down the organization. Last little bit here is that, of course, all of this is continually changing, and it's a dynamic process that's ongoing. The frame that we have allows us to ask questions like, how does our software work actually versus how we describe it, or how we imagine that it works? How does it break versus how we imagine or anticipate, try to predict it's going to break? And what do we do to keep it all working?
So the key here in this, and you can read about these things in the ACM special issues, late 19, or the individual articles are in ACM Communications in 2020. It runs through a bunch of examples of this. Notice below the line is highly automated. And whatever you are physically doing in the world, you are coming closer and closer to the enterprise software world or others in order for people to effectively, efficiently, and rapidly develop capabilities. So if you're thinking of self-driving functions in cars and thinking that this doesn't connect to those, it is coming, and it's probably already there in ways that we can't see and understand. Now, what we want to talk about is back to, remember, it's about continuous change and continuous adaptation. That's what we eventually understood the paradigm to mean. So we're going to lay out how this works a little bit.
So if we start with this notion, it's, if you're not familiar with the acronym, this notion of at the beginning of a software project, quite often called a minimum viable product. You have some ideas, we're going to build this thing, this service. And then once that's validated, then let's take, for example, Zoom, right? Once you've been able to validate that this has viability, then what happens? Well, ideally, the good set of problems are ones that expand usage and use cases. And the value of whatever it is that you've put together goes up, and people will start using it. And as a result of the growth, you will discover new opportunities, new functionality, and you expand the capabilities of the software to include integrating other pieces of software or services, perhaps partnerships, and all sorts of different things. Well, as a result, this doesn't, as it turns out, make things simpler. It increases complexity in both above the line and below the line. And as a result of that, there is the potential for the discovering of new vulnerabilities, and I say that in a general sense, operational vulnerabilities, novel or unexpected behaviors, and fundamental surprises. The point that Dave got at earlier, this idea of a multi-party, is somewhat of a modern sort of dilemma. On the one hand, it's necessary in order to have some sort of valuable stuff when it comes to digital services to make use of multi-party services. What's a great example of that? Cloud platforms of any sort, other sorts of software as a service. These days, if you were to build something that needs to process payments, you won't have to build a payments processing system. There are multiple vendors who will be happy to sell you their service, and that's a thing you won't have to build yourself. Great. At the same time that it's necessary, it also introduces a risk. If you're not careful, that means that you have now these dependent services, and the boundaries between these dependent services can become barriers, and they can form new forms of brittleness. And so if we were to look back, right, this notion that that Dev and Ops in the original DevOps formation, it has reemerged in some ways. And an example, I'll give you an example of this is Dave has told the story of Slack. Slack is, if you're not familiar, enterprise software collaboration, textual, largely based. There are a number of high-profile outages, and that map that I showed earlier goes a little bit like this. It launches on AWS, the customer base grew, the tool evolves, more functionality and more infrastructure needed in order to handle the growth of usage. As a result, new forms of saturation emerged, right? The tool then evolves, and there are adaptations. What do? They do what anybody reasonably would do, was to add more or different resources, in this case, AWS infrastructure and services. But that also introduces new cognitive costs from business perspective, from technology perspective, and a responsibility between Slack and Amazon. One of the most common things that we see in our work with clients is one of the most fundamental questions when things are not working or not going well. Is it us or is it the cloud? Where does the problem lie? As a result, there was more growth. Again, you pick up the theme here, new forms of saturation. We've included some links here. The idea that adaptations increase and change the character of the complexity, not erasing it, it highlights this boundary between multi-parties. On the one hand, you have to use them. On the other hand, it doesn't come for free. If I were to sum up one of the ideas here that Dave has said already, is that successful organizations are continually investing in their in supporting their people's ability to adapt to inevitable and anticipated situations.
One of the points that John ran through in the Slack example, I want to point out, is enormously general, right? That's the key thing. While we're using this setting, and it matters in this setting, right? And how your software infrastructure is going to work and how you can deal with it. But it's also quite general. When I talked physically out there, we ran through some adaptive cycles, and that's what John just did. He ran through actually a shorthand to run through a spiral of adaptive cycles that were going on that all involve growth and success. And the paradox that we've been identifying and talking about for a number of years now is that most of the issues of complexity and adaptation come from success, right? Producing growth, which then creates new kinds of potential SNAFUs, which again, people turn out to be critical in providing the ingredients for resilient performance to compensate the snafu catching that goes on. And we see these cycles and spirals go in many, many different settings. So this isn't just about software infrastructure.
If I were to make a bit more a sort of a blunt version of this, riffing on something a friend said to me once, you're either investing in your organization's capacity to adapt, or you're losing to those that will. So we wanted to give you this concrete example, this sort of example, and we'll tell you, walk you through a little bit, not the entire thing, of a project that we did with Mile 2. I was doing some work for the, excuse me, Air Force Research Lab. Our project was to develop, do a scoping study and develop some prototypical support for critical services applications that they're building. Now, of course, they were building within the DoD context, and that was attractive for us for a number of different reasons that you'll see. This idea of fragmentation, the potential for fragmentation, that is to say, the people who are developing the software, in this case, Mal 2, were not going to be also responsible for the platform on which the software was running and being operated, right? How could, in those scenarios, how could adaptive capacity be provisioned in advance despite the gaps? And so one of the results, there's more results than just this, but one of the results I wanted to highlight was this envisioning exercise, right? These are tabletop scenario simulations used to probe expertise. And the idea was to capture aspects of the demands that future systems might generate for engineers. We wanted to characterize features that were likely to be important, and then identify leverage points so that they could use that as fuel effectively. And so the frame was to carry out this tabletop simulations, record and transcribe and analyze those, and then use that as a focus of discussion. We developed about 4 or so. The idea there is, yep, this is exactly what I just said. And the purpose, of course, was to surface these difficulties. Now, each of the scenarios were multidimensional. There had elements of uncertainty, time pressure, constraints on actions that people could take, and potential for high value loss in each of them. They would describe or sort of propose as prompts problems that would arise during normal sort of operations of running applications on a high security cloud provider. In this case, it was platform 1. And each scenario is about an hour. So this is sort of the simplified picture. We have what we would call the home team, the developers of the application, the client, as people who are using the application, and the platform on which it is running. That dotted line is there to indicate that there is effectively I'm trying not to say firewall, but a very stern boundary. And so what do these look like? They look like first one is a report relayed from the field, right? The people using it. And the scenario is that there's not much other than it's not working, right? There's the available logs don't guide the team to any particular event that seems to be triggering or related, relevant, causal. And the application developers, the home team, become aware of some similar non-specific uncorrelated reports. What do we do with that? Run through these other examples. Now, other scenarios report relayed from the platform operations, right? And they come to the home team and say that there are some processes associated with the application running at 100% CPU, and they want to know if they can kill those if they can kill those processes. And then of course, this raises issues about whether it can be done safely to kill those, and what are the ramifications of doing that, and what sort of restart is required. The third scenario is that an application is unreachable from within the application, the home team, the application developers. They can't get to it, but it's also unclear whether or not the application is down for everybody or just for the home team. And then adding a bit more complication is that it has seen heavy traffic load recently. And while the team has some past logs available to them locally, they don't have access to the live logs. Another wrench in the works from understanding perspective is deployment had just been made recently. And then finally, this is my favorite, which is that application upgrade in progress, right? A new deployment is started and the code's being approved, deployed, and that there's an acknowledgement or realization that the apps could fail in a way that produces data loss, but only under uncommon conditions. And so the code is deployed. There's uncertainty about the conditions that could produce the data loss. The further complication is that when a security issue made clear to the platform brings them to put the release process on hold. So this is some of the work. This is just an example. There's, like I said, there's much more on that project. We're coming to close to the end. I want
a good example. Yeah. And before we hit the sec part, the part of what I wanted to run through with this is this was part of the process we used to help the development, right, close the gaps that were re-emerging that we had closed before in DevOps, and to provision their system in advance with the mechanisms to be able to see when some of these things would happen. So they could get the information, so they could understand, so they could coordinate with other parties, to know when to coordinate with what other parties, what to provide those other parties, depending on how the particular loss of service was moving along relative to the other parties that were interdependent in these systems. So we were able to produce a change, right, in advance and provision these systems with things that would help when these kinds of future anomalies, surprises, and exceptions arose, as they inevitably do for all of our star performers out there have these things regularly. Remember, Facebook has been down several times in 2020. Google has had some significant outages as well. No one is immune. No one has the expertise or magic technology for this stuff not to happen to them too. Now, the next thing is, where's the SAC?
Yeah. Dave, you want to talk to this?
Okay. So John took the same picture and laid it out, except we added something to it, right? First is, right, the normal process we ran through of growth and expansion leading to new problems arising. So growth leads to new partnerships, right? People taking advantage of the success within the organization or outside the organization and linking to it, as John illustrated in the previous examples. So we have an expansive use, which, right, produces growth. So even though you were able to handle it before, you have to continue to have the capability to handle new things. So the SEC comes in, right, because you have poaching and hijacking, right? As people start to poach on your value, that can undermine you or undermine the goals you're trying to achieve, right? Poaching the values may be in a business competitive way, and now you start to lose your competitive advantage. That can happen in other ways, and it doesn't necessarily mean that there is a strict adversarial relationship. This can be done with, at certain levels, ostensible allies as well. Think about this in trade agreements, right? We're allies across Australia, England, the US perhaps. Yet in trade agreements, there is a competition for relative advantage nevertheless. So, but the bigger one is hijacking, right? And that is fundamental to both what I've been doing under the theory of graceful extensibility and what John Doyle's been doing under the advancing theory he has called diversity enabled sweet spots. And in these, we say that the developments and advances that lead us to continuous development and deployment and the utilization of all the software as a service capabilities everywhere, inevitably, unavoidably will lead to hijacking. So parasitic intrusions is the name referred to this as, and this is now where the adversaries are taking over and repurposing what was valuable to you to what's valuable to them, which of course in adversarial things means interference, right, in terms of the normal functions we would carry out. This can't be eliminated, right? It's a complexity penalty, that a side effect that comes from the growth and capabilities that we have. The issue is, how do you have architectures that limit the damage this can do, right? And allow you to recognize and respond effectively. So as John likes to say, when we work with all these different companies, what we're doing to help them deal with the anomalies and surprises that arise from the simple growth of complexity, the inherent messiness of the system, the fact that SNAFU becomes and continues to be a normal state of these of complex systems, is all the things we're doing to help them spill over into the sec side of this, independent of whether we're specifically targeting that aspect for that particular software company. And so the same things apply that started DevOps, which is we want small, rapid cycles. We want cycles with lots of feedback in the process of provisioning and modifying security-oriented aspects. And John even referred to an aspect where in the scenarios we add in a chain or something is, first of all, we have barriers. Part of the reason fragmentation is increasing again is SEC coming in and putting those barriers in place. And we have to respect those barriers, yet provide information flow that allows us to understand anomalies and how they are happening. It's hard to tell, it's actually kind of impossible to tell at the beginning of an incident whether this is a breakdown of the normal processes under varying loads, or whether this is an intrusion from an adversary that is blocking or undermining your capabilities in general or in a more targeted way. And so all the things we've been doing seem to migrate in the same direction of a paradigm shift, where we want to start developing ways to have small, rapid cycles that migrate and find a good path in terms of responding, recognizing, responding, and blocking further damage. So this is where we're trying to integrate them together.
Dave, you want to bring us home?
Yep. So our summary is the nature of providing value will stimulate use, growth, increasing scales, interdependencies, and complexity. So complexity is not a state to be battled, right? It's part of growth. DevSecOps, to be effective, is going to need to include preparatory investments to handle future anomalies, SNAFUs, poaching of value, and hijacking of infrastructure, right? And that's a different way of, and adds a different element to thinking about some of the defense aspects we have on the cyber side. Continuous deployment is growing as an approach, and we're trying to bring this into a paradigm shift in testing as well, specifically with respect to deployments of autonomy, right? So that you can have a fluent response to anomalies and its sensitivity to small ones in the process of continuous feedback. And this is particularly important in autonomy and the claims for value that autonomy is going to bring to some of the kinds of systems, especially as it migrates from what were apparently low-risk settings, like micro-targeted advertising, into higher risk settings, as when we want to use machine learning capabilities in defense applications or or support systems for defense applications. So changing this is the critical thing. We want to bring home the key here, very simple. Deploying software will lead to value, whether that software is autonomous, automation, traditionally, infrastructure, et cetera. That will stimulate growth. Growth means more change. Change means more adaptation because of the problems associated with growth and change, which will lead you to want to deploy or modify the kind of software. There's not complexity-free growth. What we're worried about particularly now is SEC becomes more critical, is breakdowns in common ground across the multiple parties with overlapping scopes of responsibility. And we have to design for new forms of coordination across the organizational or functional lines that get broken out in these multi-party developments. And again, SEC is both part of the growth and advanced capabilities by DevSecOps as being the key aspiration, but it also adds complexity and increases the chance of breakdowns at the boundaries between the different scopes of responsibility that we've seen over and over again in the incidents we track.
So those are the slides we have. I'll send the copy of them to Garth to distribute, and we have some other materials that are that we either referenced or might be of interest to you.